Hello and welcome to our discussion on quantum theory and numbers. Before we can get into understanding orbitals, we need to understand the quantum mechanics behind an electron's position in an atom. So quantum numbers will give us a specific understanding of electrons' position in the electron cloud. There are 4 different quantum numbers. They're each symbolized with a letter. I know you think of numbers, but each of the quantum numbers will represent a specific number, even though they are symbolized with letters. So N, L, M, and S are our 4 quantum numbers. This table here is going to break down each number, give us the symbol, the definition, and some details about it. You will need to know this table for a quiz next week. So please make sure that you copy this table down in your notes. The first quantum number is called the principal quantum number. It is symbolized with the letter N. And the principal quantum number indicates the average distance of the electron from the nucleus. N is the period number, so it will be a number between 1 and 7. The next quantum number is the orbital quantum number. It is symbolized with the letter L. This is the subshell, and it indicates the shape of the orbital. The shapes are labeled by letters S, P, D, and F. Our third quantum number is the magnetic quantum number. This is letter M. It will indicate the orientation in space that the orbital will take up. This will be dependent on its shape from the orbital quantum number. S will have 1 orientation, P will have 3, D will have 5, and F will have 7. And then the final quantum number is spin. This is labeled with the letter S, and it indicates the direction of spin of the electrons in an orbital. The spin is either plus half or minus half. What's interesting about the quantum numbers is that we can compare them to an address. So we can look at them as being the address of an electron. If you think about the principal quantum number, N, as being the state, we all live in the state of Michigan. So that's a general region where we live. Then letter L, or the orbital quantum number, kind of focuses in on a specific city. Our magnetic quantum number can represent the street we live on, and the spin can represent the side of the street. Now, if you look at street numbers, odd street numbers are on one side, even street numbers are on the other. Each of us have a unique address. Unless we live with our family member or friends, then each of us will have a different address. And that's very important to understand about electrons. Electrons all have different addresses. And what that means is that each electron will have its own unique set of the 4 quantum numbers. No 2 electrons in an atom will have the same 4 quantum numbers. So it's very important to note that every electron in an atom has a specific unique set of 4 quantum numbers. Let's look at each one in a little bit more detail. The principal quantum number was discovered and presented by Niels Bohr in the Bohr model of the atom. We talked about that back in chapter 4. And the principal quantum number indicates the distance from the nucleus, the size or volume of the electron's orbital, and the atom's major energy levels. The further the electron is from the nucleus, the greater the N value will be. If you look here, this is a typical Bohr diagram of an atom, with each ring representing an energy level. This is not the orbit that the atoms stay in. This is the electronic or the energy level that they will be in. And the larger the n value, the greater the volume of the electron cloud, and the greater the energy those electrons have. We will see that n can be a number anywhere between 1 and 7. The L quantum number, or the orbital quantum number, will indicate the shape. And there are 4 different shapes: S, P, D, and F. And the Bergman-Sams video goes into more detail about the S, P, D, and F orbitals. With the magnetic quantum number, our letter M, the shape is determined by the quantum number L, but M will determine how the shape is arranged in space. So the S orbital, being a spherical shape, will only be able to be arranged in one way in the 3D plane, so it has one orientation. The P orbital, or the dumbbell, can arrange itself along any of the 3 axes, the X, Y, or the Z axes. Therefore, there's 3 orientations. The D orbital, which gets more involved in shape, has 5 orientations, and then the F orbital has 7 orientations. Each orbital orientation can only hold 2 electrons. Therefore, if S has 1 orientation, it can only hold a total of 2 electrons. P has 3, so it can hold a total of 6 electrons. D has 5, it can hold a total of 10 electrons. And F has 7, so it can hold a total of 14 electrons. Make sure that you write down this information because it's going to be important in the next upcoming videos and concept that we're going to learn. The spin quantum number, or S, indicates which direction the electron spins. The 2 electrons that can be in any orbital orientation must have opposite spins. So it's going to either be plus half or minus half. The reason that the electrons will have opposite spins is to reduce the repulsion between the 2 negatively charged particles in that orbital. If we didn't have opposite spins, then the electrons could not coexist in the same orientation. To finish up our discussion on quantum numbers, I want to just briefly explain the Pauli exclusion principle. We already stated earlier on that no 2 electrons in an atom can have the same 4 sets of quantum numbers. That is actually called the Pauli exclusion principle. This principle states that each electron in an atom has a unique set of 4 quantum numbers. Therefore, a maximum of 2 electrons can occupy a single atomic orbital. Now you're going to continue on with this lesson by viewing the Bergman-Sams video of orbitals, and they go into more detail and description of how orbitals overlap and build upon each other in an atom's electron cloud.